Yeah, I'm ready.
Good evening, this is ISC 461. We will present time value of money, and this is group number 1.
So, like Professor said, we're discussing time value of money. And if I asked you guys, what is the time value of money? It's kind of a weird question because money and time shouldn't really be changing. We're going to address this issue in our presentation today. My colleagues and I are, this is Sheldon, Kwok, Victor Bouchang, and Sarah McGray, and I'm Madeline. And the schedule for today will be looking at something like this. We will, first I'll cover the introduction. We'll talk about the concept and the general idea behind what time value is. Next, Sheldon will talk about interest and compounding it. Lastly, we will kind of mix the last two together, and we'll close on a note of annuity, which is a uniform series of cash flows. This will be introduced by Sarah and closed out by Victor. So let's get to it. Time value of money, right? You think of money as a counter or as an amount, it shouldn't really change, right? Because it'd be a kind of crappy counter if the amount it was counting always changed. So this is, why is this amount versus value? What does this say? If I asked you, would you want $100 now or $100 later? Intrinsically, most people would say I want $100 now. So there's this inherent idea that money now is worth more than money later. So what exactly is this? The internet example uses $10,000, and for simplicity's sake, we'll just keep with $10,000. So $10,000 now versus $10,000. What is the difference between $10,000 now and $10,000 in 3 years? And the answer is 3 years. And this brings this idea of, time is money. And in order to put a value on how much time is important, you have to look at this idea of interest, like a rate. There's many ways you can make money off your money over time, and one way to do it is to just rent it out like a car. Like you lease a car out, you pay money, you get the car, and then at the end, you give the car back. So if you rent someone your money, you charge them how much you want to charge them for the rent. At the end of the time, you get your money back plus rent. So this can be seen in this example where it's, at the start you get $10,000 and you get $10,000 plus interest or rent. Here you get $10,000 and $10,000 less rent. So what's the difference? If you look at it at 4.5%, like the example on the internet uses, you end up with if you choose option B and you choose to get your money later, what actually happens is you get $10,000. It's like saying you invested X amount of dollars and got $10,000 at the end. This would be like saying you invested $8,796.97 here and got interest here. Conversely, if you had chosen option A and chosen your money to get your money now, you would get $10,000 plus whatever money you rented here. This concept can also be transferred to annuity, where the difference is you get a payment at period 1, right? You don't get to charge interest. You don't get to charge rent over this period because you don't have it. If you get interest on 2, you can only charge rent on this portion. So this idea is like annuities is you only get interest on subsequent periods. So with that said, I'll pass it over to Sheldon, who will talk about interest.
Alright, so first I guess I would like to start off with introducing just a few simple definitions. Interest over here is the rent charged for the use of borrowed money, as Matt said earlier. So I guess we might ask, why do we want interest? Like Matt also said, time is money. And when, let's say, you borrow money from the bank, that means the bank is unable to use the money that you just borrowed. And therefore, the bank would like some compensation for not having the ability to use the money. So that's why they charge interest. So this can also be represented by the concept of an opportunity cost. That is the cost of the next best option you choose when making a decision. So here's a comic on the right that illustrates this. So this girl is asking, oh, so why don't you fill up at the gas station? It's here, 5 minutes away, and it's cheaper. And the guy says, because a penny saved is a penny earned. So in his calculations, he realizes that when you drive to the cheaper gas station, you're actually using up more gas, and then you would actually lose money than by saving maybe 2 or 5 cents by shopping at the cheaper gas station. So that's the opportunity cost of that scenario. And another definition, the interest rate, that is a pure mathematical number. represented by a percentage that shows the interest charged over a period of time. So here I have a few simple examples for interest. Let's assume the rate is very generous, 50%, as used in this example. And the period is 1 year for each interest compound. So in the simple interest example, you don't compound, you just get interest based off of your principal, which in this case is $100. So at the end of the first year, you get 50% of your principal, which is $50, and at the end of the second year, you get 50% of your principal, so just another $50. So in this case, you don't really gain a lot more money. But in the compounding interest scenario, you you gain interest based off of how much money you have at the end of each period. So let's start again at year 1. You get $50 based off of $100 from the initial. And at the end of year 2, you actually get $75 based off the initial, because at the end of year 1, you gain $150, and you're taking 50% of that, so that's $75. So now you have a total of $225. So here is the mathematical representation in order to calculate interest. F is the equivalent future value, P is the present value, I is the interest rate, and N is the number of periods. So in this comic here, this person's kind of confused, like, oh, like what's compounding? So let's say we have a 2% interest with $1,000 present value, and this person puts it in their computer and gets a value of $1,219. So here, I did out the math to check to see if the author did it correctly. So we have P as 1,000, I as 2%, which is also 0.02, and the period, there's 10 periods for 10 years. And you just plug that into a calculator and you get $1,218.99. So basically $1,219, and the author did it correct. So yeah, so compound interest is not some magical force that it's difficult to understand. You can also compound your interest continuously. So instead of like easy to visualize, understand intervals of like monthly, daily, or like annually, you can compound as the time approaches infinity. So just like instantaneously compounding. So this is defined by this equation here. As before, F and P. So F is the future value, P is the present value. And then here we have E, the exponential factor. And then we have R, which is the rate, and T, which is the number of periods. So we use the same number from before, where the interest rate is 2%, and the present value is 1,000, and just plug it in there over 10 periods, and you get $1,221. So that's like slightly more than $1,292, but every dollar counts. And in scenarios where you're dealing with large amounts of money, you can make more money from compounding continuously. And here's just a small joke. The E's telling the pie, oh sure, everybody loves pie, but sooner or later their interest converges on me. And with that, I'd like to hand it off. And Sarah will talk about annuities.
Okay, so what are annuities? Basically what they are is a financial product that is designed to pay out a steady amount of cash over time. So it's more like a car payment or depositing to savings account. So you want like $200 every month into the account. You can use that value to increase your value at the end of a certain amount of time. Here are the equations from our textbook. Here's the series worth factor, which will be used to find the equivalent present value. So that there are different types of annuity. There's ordinary annuity where payments are made at the end of the period, and here is the equation with A being the annuity value, and then P being the present value, and N is the number of periods, and I is the percent interest. Then there's annuity due, which payments are made at the beginning of each period, like rent payments, and then there's fixed annuities that are annuities with fixed payments, as it says, there's a predetermined return from the insurance company or the bank, whatever you're entrusting the money to. And then there are variable annuities where The benefits are periodic payments, death benefits, and tax deferment. And the amount of money paid out every period varies, so you can put in $200, and sometimes you get up $50 to $75 or $80, depending on the annuity. So I'll pass it over to Victor to give you a few examples of factors.
When we're looking at annuities, there are 4 equivalence factors that impact the present, future, and by how much you're going to be regularly inputting, or what the amount you're going to be regularly inputting. And these are the present worth factor, the capital recovery factor, compound amount factor, and sinking fund factor. So the series present worth factor is the factor that allows us to calculate from knowing how much we regularly input into the annuity, how much the present value of the annuity is. And so an example would be, we want to know how much we need to invest at present to have an annuity of $50,000 a year for 5 years, knowing that the interest is 10% per year. So in this case, our annuity is $50,000. Our interest rate is 10%, and our period is 5. And by plugging these values into the formula that we took from the textbook, we find that the present value would be $189,539. Another factor is the capital recovery factor. The capital recovery factor is used to find out how much we would regularly deposit or withdraw in an annuity to match present value, or also how many periods we would want to we would need to pay to complete the annuity. So an example would be, in this case, we want to find out how many years it will take to empty an account. We withdraw $1,000 each year, starting from $10,000 capital, and the interest rate is 5%. So in this case, our present value is $10,000, our annuity is $1,000, and our interest rate is 5%. So in this case, it's hard to solve for n, but by looking into the compound interest tables, we're able to find that the period, it would require 14 periods to empty the account. Then there's the series compound amount factor. The series compound amount factor is used to find out the future value of an annuity. It's very similar to the series present worth factor, except you factor out the 1 plus I to the power of n, which is the equivalent of calculating the present value. And so an example would be, imagine that you are planning for your retirement. You expect to retire in 35 years, so you save around $500 per month with 8% interest per year. Question is, how much would you have when you retire? And by plugging in these values into the equation, we get $1,146,941. And finally, we have the sinking fund factor. The sinking fund factor is actually the inverse of the series compound amount factor. It allows us to find out how much to deposit or withdraw in the annuity to match the future value. For example, we want to find out how much we should deposit into an account in order to save up $60,000 in 5 years with an interest rate of 10%. So in this case, our future value is $60,000, our period is 5, and our interest rate is 10%. And by plugging these values into the formula, we find $9,828 per year. Sarah is going to conclude our presentation.
Just to conclude, just to review what we learned, that interest is the rent charge for the use of borrowed money, so it can increase the amount of money when you put it into a fund, like Sheldon gave the example of. And annuity is equal payments over time, which can also increase the value of your money in the future. And then, as we've learned, it's always better to have money now because you don't know what the interest is going to
concerns,
Um,
or